Plastic skin is a very serious disease that affects 90% of all AI portraits. Here, at the Center for Plastic Skin, we are trying to solve it. One day at a time, we are getting closer and closer to a goal. But we need your help. Hello and welcome to another episode of Stable Diffusion Experimental. Today, we'll be taking a look at how we can try to solve plastic skin in AI-generated people. Now, I am not close to a definite solution yet, but I just wanted to show you which steps I'm taking in order to try to solve this problem. Now, first of all, what do I mean when I talk about plastic skin? Skin that has been AI generated has this kind of issue where the skin is almost always too perfect, too shiny and without much detail, and overall it has no imperfections. It's very flat and the color is mostly constant. Yes, you might have different light reflections or light hues, like in here or in here, where you have lights from the surroundings bouncing off the skin, but overall the skin tone itself is very predictable. Real skin, however, doesn't look like that. And that's mostly because real skin is made of a ton of layers. And as such, it's very similar to onions and ogres. Yes, you've got the first layer of skin, which is the epidermis, where all the skin texture happens with your pores and facial hair and what have you. But you also have underlying layers. The actual dermis with all its blood vessels and meat. And then you have fat, bones, what have you. And all of these layers add complexity to someone's skin tones. Something that just doesn't happen with generative AI. In the 3D space, we have something called subsurface scattering that can help with giving back some texture to materials such as skin, but it can also be used for other things such as marble. And it's all based on the fact that while some rays of light get reflected by the first layer, the epidermis, some other rays, before getting reflected, get trapped underneath the epidermis and so follow different paths, adding complexity to the light that we see reflected off someone's face or skin. Now, of course, we do not have that in generative AI, and what we have access to instead is Photoshop-like blending tools for layers. And so what I'm trying to do is making the most out of this. Now, I will explain everything that is going on here in this timeline of changes that are happening gradually, and you can find this workflow, quote unquote, because it's not really a workflow really, it's more of a demonstration, in the description below if you want to follow along or use it yourself. And apart from this FaceDetailer pass, we're not even using any models, we are just using blending options. So we are not necessarily trying to generate anything, we are mostly trying to correct something exposed. Talking about the tools that we have at our own disposal, I am mostly using two. We are starting from a pre-generated asset, which in this case is this image over here, and we are using automatic segmentation and random noise. And it will all make sense in a second. First of all, we can see that the base image skin is very plasticky. There is virtually no texture except some highlights here on just one of the cheekbones, the nose bridge here, and a bit on the chin. But if you take a look at how the skin changes in color over the more recessed areas, there's basically no texture involved around these areas. We don't have any skin pores, we don't have an imperfection, we don't have anything beside color. So the first thing that we're going to do is find the face and segment the face in order to work only on the face. In order to do that, we are using YOLO Face in its segment form, not the B-box form, because we don't need a square, we need the actual face mask. Once we found that, we are cropping both the original image and its mask by its mask coordinates, and here we are getting the crop for the face, and we will be working only on that. Now, the first thing that we are going to add is skin pores or skin texture. And if you really think about it, what are skin pores and how are they distributed on your face if not through random noise? There are many different ways of random noise, but for this one instance, let's focus on these two types of random noise, which are Perlin here on the left and Voronoi here on the right. Out of these two, Perlin has more of a regular noise kind of structure. It's more familiar, whereas Voronoi has more of a cell-like structure, which is great because skin pores and skin texture in general is very cellular-like. So we want to drive new noise creation over the skin by using both of these noises. But these two noises here are too big. If this is the face size, then this cellular-like structure is way too big and this noise pattern is way too big as well. So what we want to do is create some noise that is the appropriate size to the face's size. Now, in the future, I want this process to be automated based on the face's size, but right now I don't have access to nodes that create noise in the way that I wanted to, so I'm doing this manually. In the future, I would like all of this process to be just 1 or 2 nodes, but for now we will have to make do. So by changing the parameters on both the Perlin noise and the Voronoi noise, I am finally creating a noise pattern that is the appropriate size, or close to the appropriate size, for the face dimensions. But then we have an issue, and I will show you that on the face as well. But this noise pattern is very well defined, and it's going to create some very sharp details on the skin. And we don't necessarily want that, because the image is not that sharp to begin with. So in order to fix that, I am applying some blur. Now I'm going to bypass this blur node, and I'm going to show you what happens if we don't apply that. Now here, what's happening is that we are applying the skin pores texture on the original face. Here we can see the original face. You can see a hard light blending mode of the skin texture over the original image at 100% of blend percentage. We can see that that's way too much, and so we are using the same method here in the third image with a lighter percentage, so 0.3 in this case, but you can modulate it if necessary. In the last step, we are applying this image here to the original image by driving it only on the face with the face mask. And we can see here that if we don't blur the skin pores texture, it's going to be way too detailed, and it's going to create this weird texture on the face. But if we go ahead and reapply the blur, we can see how the result now is much better. It's not perfect yet though, and that's because we are applying a purely black and white texture map on a colored image through hard light, and that washes away colors, which is not good for what we want to do. And so in order to solve that issue, I'm going to apply this group over here, which takes the color of the skin by using a color picker and then applies that color to the noise. And this way the result is already much better. Now it's not finished yet, we have just applied some texture over to the skin. We are applying this texture map evenly throughout the face, regardless of what the face's characteristics are. For example, crevices, things that are more in tension, parts that should have a denser texture, parts that should be more elastic. In order to solve that issue, since we don't properly have a heat map showcasing these stress areas, I thought about using a depth map as a mask. So applying the texture more in the parts that are closer to us and less to the parts that are further away from us. Now this overall is very much an approximation, but the reasoning for this is that all things being equal, the parts that are closer to us in a portrait are the parts that protrude more than others on the same plane. And you can see here that the parts that protrude less are the crevices around the eyes, around the cheeks, around the nose, and the parts that protrude more are the nose, the lips, the eyebrows, etc. Now here I am remapping the map in order to shift the gray point a bit and drive the texture distribution a bit more in a custom way. But this is the result that we get by applying the skin texture through the depth map. And this is a comparison between applying it all evenly without a depth map in this case and applying it through the depth map like in this case. Now the difference is very, very, very low. But in this case you can see that you have less noise around this depressed area and you have more noise around the more elevated areas. Now on to fixing color variations throughout the skin. Usually on faces in depressed areas such as the eye pits, we have some hues that are more bluish or greenish in tones. It's just the way that blood vessels work. In order to approximate that, I am inverting the texture that I've used to drive the skin texture blending in order to create a sort of complementary color. Now, this could be bluish, this could be greenish, it all depends on your complexion, but I feel like this is a close enough approximation. I am also inverting the depth map because I want to drive this complementary skin color over to the most recessed areas. And you can see here that the areas that will affect the most are the areas that are deeper inside of the picture. And so here we can see how the texture is applied through multiply at 100%, but that's too much. And so we are lowering it to 50%. And then we are applying it only to the face through the face mask. And we can see here a comparison between the before and the after. Before, after. It's not much, but it's adding a bit more depth to the skin. It's adding a bit more complexity to the skin. Then we are doing the opposite on the parts that should be highlighted, that should catch some more light. And in order to do that, we are resurrecting the starting noise map with the correct skin color, not its complementary, and the non-inverted depth map. And we are applying that texture with an overlay blending mode at 100%. Once again, that's way too much. And so we are lowering that to 50%. Basically the opposite of the multiply before. And then we are applying that only to the face. And this is the before and the after of applying that before and after. We can see that we get way more texture now with all these steps that I've accumulated one after another. Now here I am running a comparison, and we can use this or not, that's fine by me, in order to arrive at the final image. But this was more of a sanity check for me, just to check with myself if what I was doing had any actual effects. And so I am doing a FaceDetailer step on both the new image with the new texture and the original image here on the right. As we can see, all the parameters are the same. We're using a denoise of 0.25, 20 steps at CFG1 because we are using flux. And we can see here the difference that we get. Here we have the FaceDetailer pass applied to the original image, which is still plasticky. It's better, but it still feels plasticky. And the FaceDetailer pass applied to the retextured image, which to me feels great. It's not perfect yet, and I feel like it changes too much of the face. And that's probably because there's more noise now, and so it's latching on to the original face a bit less. But overall, the skin details and the complexity in the skin is brought back. It's much more realistic to me. It doesn't look like a badly applied Instagram filter or an overly photoshopped picture. And at the end here, we are actually blending back the face on top of the body by using the bounded image blend node, and we can see here the before and after. Before and after. Now this seems to be working well over a variety of skin tones, no matter how plasticky the original face was. Like in this case the skin was very plasticky, and it still brought back quite a lot of details, quite a lot of variations, quite a lot of texture. And also it doesn't really matter what the skin tone looked like in the beginning, it's still capable of working with uncommon hues, like in this case where it was all very blue. Now there are still a couple of problems, like in this case you can see that it's very exaggerated, the fact that it's applying way too much texture. And it's veering off to this sort of freckles look, which I don't necessarily hate, but it's not exactly what I wanted to do. The main culprit here is the noise. Originally I wanted to work with Voronoi mainly and Perlin less, and driving Voronoi through Perlin, but instead I'm doing the opposite, mainly because the Voronoi node that I have access to is kind of limited and only outputs this as the minimum size of the Voronoi cells. In the future I will create a node that allows me to create smaller Voronoi cells, and so I would be able to rely less and less on this noise structure, which is the Perlin noise. Another issue is that this is not elegant. This, while yes, it's technically a workflow, it's not easily applicable to any other workflow out there. Yes, you can use it as a standalone workflow and you can just plug in an image here and make it work, but it would be much better if it was just one or two nodes. And so I'll be working towards that as well. But all in all, results are very good, at least for something that I've thrown together in a couple of days, especially when compared to a simple FaceDetailer pass like we can see here. So I'm definitely going to work more on this, because I think that the use case for this is pretty wide. So all in all, pretty excited about all of this. And I hope this didn't sound like the ramblings of someone who went too much off the deep end with random noise and skin layerings. If you like this video, leave a like and subscribe. My name is Andrea Baioni. You can find me on Instagram @reasonbushi or on the web at andreabaioni.com. And same as always, I will be seeing you next time.